Hello, I'm Diallo Cummins, and in this session we'll take a look at rational functions and expressions. And here are our objectives. We will define rational expressions, we'll define rational functions and describe their domains, we'll write rational expressions in lowest terms, we'll also multiply and divide rational expressions. In this slide we see the definition of a rational function, and it also describes the domain. A rational function has the form f of x is equal to p of x divided by q of x. Note that both the numerator and the denominator contain polynomials, where q of x is not equal to 0. The domain of a rational function includes all the real numbers except those that make the denominator equal to 0. We see the set builder notation, and this is read as all real numbers p divided by q, and the vertical bar that you see means such that p and q are polynomials with q not equal to 0. So let's take a look at a couple of examples. In this first example, we're asked to find all of the numbers not in the domain of the function and then give the domain in set notation. We know that the domain of a rational function is restricted to real numbers that do not cause the denominator to equal to 0. So we'll simply take the denominator, we'll set it equal to 0, and we'll determine which of the values must be excluded from the domain. So I'll simply take the denominator, I'll set it equal to 0, and I'll solve it for x. So I'll simply add 4 to both sides. I have x equal to 4. And to write out our domain in set notation, I have all real numbers x such that x is not equal to 4. And this is the domain in set notation of our rational function. Let's take a look at another example. And in this example, we're asked to write the rational expression in lowest terms, 3y squared minus 17y plus 20 divided by 3y squared minus 16y plus 16. So I simply factor the top, factor the bottom, cancel common factors, and we'll write out our simplified result. When we factor the numerator, I'm going to make 2 sets of parentheses. 3y squared minus 17y plus 20 factors to give us 3y minus 5 and y minus 4. 3y squared minus 16y plus 16, that factors down to give us 3y minus 4 and y minus 4. Next, I'll cancel the common factors. So our simplified result is 3y minus 5 divided by 3y minus 4. Next, we'll take a look at multiplying rational expressions. And to multiply rational expressions, we'll follow 4 steps. The first step is to factor all numerators and denominators as completely as possible. Third step is we'll apply the fundamental property, so we'll cancel common factors. The third step is we'll multiply the remaining factors in the numerator, and we'll multiply all the remaining factors in the denominator. We'll leave the denominator in a factored form, and then we'll check the proposed product. And in this first example, we're asked to multiply r plus 2 times r plus 4 over r plus 5 times r plus 2 times r plus 5 times r plus 8 and in this example we're asked to multiply the following. So I'll simply use the fundamental property. So I'll cancel common factors within numerators and denominators. So notice we have an r plus 2 factor here in this numerator, which will cancel the r plus 2 in the denominator. We have an r plus 5 that'll cancel out another r plus 5. We also have an r plus 4. So our simplified result here is r plus 8 divided by r minus 2. In this example, we have to factor all of the numerators and denominators, apply the fundamental principle, and then write out our simplified result. So first we'll factor a squared plus 2a minus 63. So I'll make two sets of parentheses, and that factors down to give us a plus 9 times the quantity a minus 7. I'll also factor the denominator a squared plus 3a minus 70, and that denominator factors to give us a plus 10 times the quantity a minus 7. I'll now factor the other numerator and denominator. We'll factor a squared minus 8a minus 20, and that factors to give us a minus 10 times the quantity a plus 2. And when I factor my last denominator, a squared plus 11a plus 18, we get a plus 9 times the quantity a plus 2. So now we'll use our fundamental principle. So we can cancel the a plus 9. We can cancel the a minus 7s. We can cancel the a plus 2. And our simplified result is a minus 10 divided by